When a dataset contains multiple variables, the scale of each variable can influence the measures of distance, our Euclidean and Manhattan measures. For example, comparing revenues of restaurants with the rating of each restaurant location from a review website. Revenues are objectively larger numbers than the ratings, which range from values of 1 to 10. This means that revenue will have a greater influence on the similarity measure we're using. Standardizing and normalizing are approaches we have to reduce the effect of this problem and make observations unit-free before calculating a similarity measure. So I'm going to review how to compute z-scores to standardized data and the min-max transformation for normalization. So let's start by standardizing our revenues and business ratings. To standardize our observations for revenue, we first have to calculate its average and standard deviation. So in cell B12 here, I'm going to calculate the average revenue at all 10 of the restaurant locations. Next cell, I'm going to use the average function. Then I'm going to highlight the revenue for the 10 locations. And we find that there is an average revenue of $860,310. I'm also going to go ahead and calculate the standard deviation for this sample of restaurant locations. Again, the STDEV function, and I'm using S because this is a sample. And the standard deviation is about 234,704. So now that I have these calculated, we can divide the difference between each observation and the mean by the standard deviation. So up here where it says standardized revenue, I'm going to type out the equation that is represented down here around row 18 and 19, but using the specific cells referenced in this spreadsheet. So I'm interested in, I'm going to divide the first observation for our revenue, so cell B2. And I'm subtracting from that the mean, which is in cell B12. I'm going to use the dollar sign before the letter B and again before the number 11 so that I can really easily copy this formula down the column without having to worry about adjusting that cell each time. Meanwhile, B2, I don't want to do that too because if I copy and then paste this equation down the column, I want it to change that first observation with whatever observation is in that row. Then I'm going to divide this by my standard deviation, which is in cell B13. So what we find here is that our standardized revenue for restaurant number 1 is minus 1.45-ish. And then I can copy this formula and I can drag it on down and then paste it, and we can see the rest of the standardized values for revenue. So we see that the scale and difference in the size of the numbers is now a fair bit smaller than we see in column B, which is our original data. And then we can go ahead and do the same thing with our business ratings. Again, taking the average of our business ratings for the 10 restaurant locations we're interested in. Looks to be about 5.2. And then we also want to get the standard deviation of this sample. And we find that that's about 2.29, 2.3. And then we can go ahead and we can populate the same equation that we did in column D in column E. But now instead of being interested in revenue, we're interested in business rating. So we are going to start by looking at the business rating for our first restaurant in cell C2, and from that we're going to subtract our average or mean value, which is in C12, and we're going to divide that by the standard deviation. And we find that our rating is equal to minus 0.9566-ish, and we can copy and paste down the length of the column. And we see that even though the range of values from 1 to 10 really wasn't that broad, we've sort of condensed it a little bit more. And what we do see is that now the values for standardized revenue and standardized ratings are not terribly different from each other. And just to sort of illustrate how this could look different, we can highlight these columns and look into dropping in a chart, like a scatter plot. And here is the scatter plot of the business ratings on the y-axis and revenue on the x-axis, and we see our values are distributed like this. And then we can create a chart with our standardized values. And find that the distribution of the values and the scale is virtually the same on both axes, whereas the scale in the original chart was very different on the x and y axes. So that's sort of an illustration of why this is a very helpful thing to do. But we'll make these visualizations disappear and move on to normalization. So to use the min-max transformation to normalize the revenue and business rating variables, we first need to find the minimum and maximum values for those variables. So in Excel, they very conveniently have a min function. Which in this case is $527,100. And we can do the same with the max function. We find the maximum is about $1.2 million. And then our range is going to be the minimum subtracted from the maximum value. So our max value is in cell B15, and our minimum is in cell B14. So we find that our range is about $708,000. And then we can actually just copy these formulas and paste them right next door beneath the business ratings values and see very different values for them, but derived from the same calculations. Although in this case, our business ratings are not expressed in dollars, so we can go into format cells and just go back to a general formatting because ratings are not expressed in dollars. So now in column F, I can go ahead and I can normalize the revenue values. So for this, I'm going to start with my revenue for restaurant location number 1, which is in cell B2. And from that, I'm going to subtract our minimum value, which is in cell B14. And then we're going to divide that by the range, which we have in cell B16. And we see we have a value of 0. One thing to consider when you're normalizing variables is that all of the outcomes are going to fill a range from 0 to 1. And our lowest, in this case, revenue, is going to be the normalized value that comes back as 0, whereas our highest revenue location, which is location 10, is going to be presented as the number 1. And now we can go ahead and apply the same type of calculation, but to our business rating instead of our revenue variable. So here I'm looking at C2, and from C2 I want to subtract the minimum, which is in cell C14. And then I want to divide that by our range, which is in cell C16. I'm going to copy and paste that down the column. And we see in this case that it's restaurant number 2 that had the lowest rating, and that it was restaurant number 7 that had the highest rating. So those are our bounds of 0 and 1, and then everything else is calculated to be between those values of 0 and 1. So I hope this helps you understand how we can go about standardizing and normalizing multivariate data sets to help us calculate the best and most accurate measures of distance between points when we're developing a data mining application.